Hello everyone, Murat here. Today I'm going to talk about how to build a simple staking contract in Solidity. Um, this will be a short video. I'm not gonna show you how to I'm not gonna write the code. I already wrote it. I'm going to give you the code to GitHub, the GitHub repo in the description. What are we going to build? Let's see. Well, what is staking? It's basically people will put money, the users will put money into the system, and depending of the time and the amount of money they put, they will claim rewards. They will get some return for their stakes. uh, there is a good readme that I made AI write. It's so good. Let's directly start. So um, this is not for extreme beginners. Like, I need you to be somewhat knowledgeable uh, in smart contract development. Now let's see. Oh, this is the test. Sorry. Let me. Yeah. So you see, we have our Pragma, we have our SPDX license identifier, and we are importing some uh, Open Zeppelin contracts, IERC20, Safe ERC20, ownable, reentrancy guard, pausable. Um, what are they? Why are they? Why do we need that? If we are using uh, if we are using ERC20 tokens that are not mainstream, not mainstream, like not to the standard, say ERC20 is the best. We need the contract to be ownable. We need reentrancy guard, because reentrancy, which was a very famous hack back in the days. Today it's difficult to come around, but still you can find it. We are not going to go over it. Let's see what's going on. Our contract is simple staking. It's ownable, reentrancy guard, pausable. We are using Safe ERC20 for our ERC20 interface. We are defining our reward token, annual reward percent, which will be 10 for 10% annual return. I hope you can understand my broken English. Um, yeah, it's recording. Well, it says seconds per year, but I wrote to 365 days. Like, I spent 2 hours building the whole project, so bear with me. It's in days. You can change it. It's confusing now, I realize. Too bad for you guys. We have a public constant minimum stake, which means users can stake minimum 0.01 ether. If they try to stake less, they should see an error. We have a stake infrastructure. Okay, you can read this. We have these, like, staked amount. Because we have to take into account, we have to follow what the user is doing. And so we have the stake amount, rewards earned, last update time, which we will see, and we have events. We have our stakes mapping that takes an address and shows the above stake info struct. Let's go to our constructor. Constructor, is a function that only runs once in deployment. We pass the address of the reward token in the token which the stakers will get their rewards. And on annual reward percent, which will be 10 in the tests. I did 10, I guess. Let's see. Yeah, you see, I did 10 here. Yeah, because the only reason I did that, for simplicity. So again, what are we building? I'm a user. I will put my money into your protocol, into your contract, and I will get some return from it. That's simple, very basic. So we need to calculate the rewards. This is the calculation, the math. We get the staked amount, say 100 ether, how much we staked, and what is the percent, and we divide it by 350, 365 days. which is here, and we use 100 for scaling. Um, you see this calculate rewards fork function is called by this update rewards function, and which will be called in many operations. You can see it's basically called almost every function that we have. And what functions do we have? Let's go back to our readme. We have stake, unstake, withdraw at, like which is partial withdrawal, claim rewards. I want to get my rewards. Emergency withdrawal. What happened? What? Emergency withdrawal. I will forfeit rewards. I get the staked ether that I put. I didn't really check those functions, and this pending rewards. We view unclaimed rewards. You can check them. I wrote them quite fast. Mm, there are owner functions, fund rewards, because like I as the owner have to put some money to the contract so the users, the stakers, can get their rewards. Um, okay, let's go. This is the test file. We need the original file. Yeah. So first I want to stake. Okay, we will go to update rewards right now. Okay, let's go to update rewards. Like we get the stake info of the user with the mapping. Like we pass the user address and the mapping takes us to the stake info here. You know how much the user staked, how much reward they earned, and when was the last time it got updated. This is important. Why? We will see. Um, If user has staked amount, calculate reward since last update. You see, we check if the user has staked more than 0, and then we check block timestamp, which means say now minus the last update time. We calculate the rewards with the how much amount has passed, and then add rewards. Why? The idea is, imagine the situation that a user used, there is Alice and Bob. Okay, Alice, let's say we have only Alice. In a whole year period, Alice first deposits the bare minimum amount, which is 0.01 ether, which we have defined here, to the protocol, and starts earning rewards. Okay, and then again, this is an hypothetical situation, and let's say after a year she decides to get her rewards back, so she deposits 100 ether and then calls claim rewards. If we didn't do this update rewards issue, if we followed a more naive approach, Alice, the user, would get uh, the not the initial amount they put, which was very small, which stayed in the contract for a whole year and didn't contribute to the system in general much, but the last amount, like the 100 ether, just before claiming their rewards. And so they would get a lot of rewards which they don't merit. So we are using this logic to go over that. So let's move on. We have the stake function. You see, anyone can call. It's public, it's payable, which means you can pay at ether with like native token, which with this function, and it's when not paused, because we are using pausable from OpenZeppelin. We can use this modifier. So here we are checking if the message value is equal or bigger than minimum stake. We get the checkpoint, we update rewards. Right now we don't have anything, but in the next time, let's say the user wants to stake, like they staked once, after some time they stake again because they get more money, they want to earn more rewards, etc., etc. So update rewards function is called, we just talked about it. Then we get update user stake, because we, like the user staked some amount, we update it with the message value, which is the amount they pay using this function, and we increment the total stake because we probably want to keep a track of how much money has been staked, how much ether has been staked in the contract, and we emit an event. Easy peasy. Now unstake. First, like, because users would like to unstake. And what does unstake do? We will see. First, it requires that there's some amount of minimum stake. We are updating rewards. We are getting the stake amount of the user, you see. And here, also this is non-reentrant, so you cannot just use reentrancy attack here because we will see soon. In unstake function, the user takes everything they have. Okay, they just leave the protocol pretty much. So we zero their staked amount and decrement, they subtract the staked amount from the total staked. Now we update the users rewards. We get the users rewards earned. You see, we are checking the address of this balance to see if we can pay the rewards or not. We should be able to pay it. And then again, we zero the rewards earned. Now reward token, safe transfer, message sender. Message sender is the caller. We transfer the reward token to the user. This is basic. But here you will see, now we are going to send ether because the users, they staked ether and native token, and they will get native token ether. But you see, I put a note here. It says we keep this as cautionary example. So first look what's going on here. So there is this native transfer function that you can transfer ether native token with Solidity. You see, payable message sender transfer staked amount. So we can do that, but this is not a good approach. Why it's not a good approach? I'll come to that. Instead, we do this. This is the low level call method. We are using this. It has a bit of weird syntax if you are not used to it. Basically, it returns a couple of stuff. One of is whether it was successful or not, and we have to check if it's successful or not, because it might not be successful, and that will be bad for us, because if it's not successful, the user will not receive their ether, but our function will just continue, and like basically the user will lose their money. Let's go back to why we are not using transfer but the low level call method. Well, the reason is with transfer method you can only say the user is a smart contract, okay, and when we send ether to the smart contract, they get it with receive function, which should be around here, yes, and they might do something with that ether. The problem, transfer function can only accommodate 2300 gas. If any functionality after the in the moment that the user contract, or like let's say it's not a wallet but it's a contract, and it gets the ether and it does something to it. Let's say it's a DAO or some multi-sig wallet. It has many users. They get the ether back and it's distributed there, and it takes a lot of gas. This function will fail because this transfer cannot accommodate 2300 gas. So that's why we are using this low level call. Let's go to claim rewards. We can claim rewards. Again, we are updating rewards. It's very important. We have to update rewards each time we update the state. We check if the user earned any rewards. We update the user stakes. We are doing our checks, and we are sending the reward token to the user. Emergency withdraw. As you can see, we are not getting any rewards. We are just zeroing everything. We are getting the Now, yeah, it's okay. I just checked whether there's a bug or not. There might be a bug. I didn't audit. I didn't think much about the security of the contract apart from couple of basic things. Again, I spent maximum 2 hours. Okay, I'm not gonna lie, maybe 1 hour writing this very fast because that's it. Um, Here is we can get the see pending rewards. We don't call the update rewards because we don't want to change the last updated. This is just a view function. Fund rewards is only for the owner because we need to provide, as the owner, we need to provide some reward tokens to the protocol. Um, Again, the owner can change the annual reward rate. This might cause some problems. I'm just keeping it here so that you see like this is a possibility. But what kind of problems? Like, um, I mean, I should leave this to you. But imagine the scenario where like a user uh, deposits on a certain uh, percentage, like 10% return they will get. So they keep their uh, Ether expecting 10% of return, but the owner changes just before they claim their rewards, and their rewards calculate like owner changes to 5 or maybe 1 just before the user claims uh, their rewards, which will, they were going to get 10% return, but since the user had changed, they will get 1% return. So this is not a very safe function. um, there are many ways to go over it, but we put it just so this is not a production ready. Oh no, production ready contract. It's just so you guys can see. This is again for only owners some emergency withdrawal tokens. Like say someone accidentally sent some tokens to the contract, the owner can withdraw it. Good, everything is good. um let's open. Yeah, it's taken contract. Nice. um uh oh, I have an error. Where is the error? User, oh yeah. Sorry. Yeah, we should get an error. I wrote yeah, uh like this is normal. I was surprised why user can't stake 0 at yes, we are expecting revert here, so that's the correct behavior. I was surprised at first. I wrote this contract to tests yesterday, so I don't remember everything. um you can check the tests we have done, just to clarify what was going on here. In this test, we are trying whether the user can stake 0 Ether, and we write here that expect revert because it should revert. User shouldn't be able to stake 0 value, and it reverts. And we see that all of the tests pass, none of them are failed, so all is good. All of the tests um, passed. Again, I will give you the GitHub link. You can check the tests. They are basic. There's not much coverage. There's no invariant test or anything. This is just for heuristic purposes. We test stake and unstake, test stake and withdraw, test stake and claim. User can't put less than min stake. Oh yeah, this is interesting actually. Users shouldn't be able to. Let's go to withdraw add function. um where is it? I should do that. Yeah, there is this nice thing I added, um which is again some sort of security control. Like let's say the user put 1 Ether, which is way more than the minimum, which is 0.01 ether, but then they call withdraw at, and like they withdraw everything except one way, and they have a position with one way. We don't want that. So here we put this check: when the users are withdrawing at, they should leave at least 0.01 at amount of stake in their uh, position. So yeah, that's it. I know it was fast, but that was the idea. This is quite basic. If you have any questions, good luck. I might or might not answer them because you have AI and everything. Check the code, have fun. Um, See you in the next video. Peace out.